Okay, let's look at this. This is the replacement portion, 83C, I think. Shh. Okay, so in 83C, on the first example problem, we're talking about an urn contains 2 black marbles and 2 white marbles. Okay, a marble is drawn at random and replaced. Okay, so when they say and replaced, the second draw is going to have the same probability, right? So then it says, what is the probability that both marbles are black? Then it said if the first marble is not replaced before the second marble is drawn, what is the probability that both marbles are black? Okay, so on the first time when it's replaced, then we're going to assume we draw a black the first time because we're looking for the probability that both are black. So we assume black on the first. So the first black is what? 2 out of 4 marbles. So our black is 1/4 probability. That marble is then thrown back into the urn. And so we still have a 1/4 probability of drawing a second black. All right. Excuse me. It's 2/4. 2/4 because there's 2 blacks, 4 marbles, 2/4. Okay, so that's going to be 1/2 times 1/2, or 1/4 of a probability that I will draw both blacks. Okay? Now we're not replacing, so it's still going to be the 1/2 for the first draw. But then I assume I took a black out. So now how many blacks do I have in there?
One.
I only have 1 black in the urn. How many marbles do I have altogether? 3, because I took 1 out. So now I have a 1/6 of a chance of getting 2 blacks if I didn't replace the first one. It does change the probability. Okay, look at this one over here. Now you will see in your probability problems that a lot of times they're going to use a deck of playing cards because they are it's just something that we've done probabilities with over and over, and it's standard. Okay, so you need to know a little bit about a deck of playing cards to be able to get these done. You'll also see that, like on SATs and ACTs, they will use this in a lot of probabilities. Dice, coins, playing cards. Those are your 3 biggest probabilities because they're fixed. Okay, so in order to understand this, you need to understand that there are 52 cards in a deck. Okay, you need to understand that there are 4 suits. Okay, and those 4 suits are 13 cards each. Right, because you have 52 divided by 4. All right, you have half of your suits are red and half are black. Okay, so when you're starting to talk about probabilities, you need to know this. You also need to know that you've got what? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, king, and an ace. Okay, so you're right, ace is 1. Ace is 1. All right, so we have a 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, king, ace. All right, so if you're not familiar with the deck of cards, you just need to know that, and you'll be able to do your probabilities. Okay, so here we have this next probability problem, and it says 2 cards are drawn from a 52 card deck. So they told you about the 52 without replacement. Okay, what is the probability that the first one is red and then the second one is black? Okay, when you're talking about red, you've got half your deck as red, right? So you have 26 out of 52 cards are red. So you assume you pulled out a red card and you did not replace it. So you changed your total number of cards, but you didn't change how many black cards you have because you assume you drew a red. Okay, so now we still have 26 black cards in the deck, right? So 26 black cards remain, But now I only have 51 cards left to draw from. So the probability, this one of course is going to reduce to 1/2 times 26 over 51, or 20, let's go ahead and reduce across here, 13, okay? So we got 13 over 51 would be the probability that you would draw a red first and then a black, okay? So you want to make sure that you understand basic probability. Let's move on to 54. I would get that board.